Number 39, integral x minus 1 over x cubed plus x dx. This looks like a rational function, so maybe we can do partial fraction decomposition. And in fact, the bottom is factorable into, extend the screen share, x times x squared plus 1. There's a linear factor and there's a quadratic factor. We know how to do partial fraction decomposition for that. Okay, so we can split it out into a over x, that's for the linear factor, and then bx plus c over x squared plus 1, that's a quadratic factor, so it has to be like a linear term on top. That's why the bx plus c. Multiply both sides by the denominator, you get x minus 1 equals a times x squared plus 1 plus bx times c times x, be careful with parentheses. And then usually for this, when there's like quadratic factors, it's usually easier to match coefficients by expanding everything out and then group like terms. So we know that a plus b, because it's an x squared term on the left-hand side, the a plus b has to equal to 0. C has to match 1, and a has to match minus 1. Okay? This is why this method was a little faster, in my opinion, than plugging in values of x and all that. Because you would start to plug in 3 values of x to get your a, b, and c. But here, you would have your a and c without having to plug in anything. Okay? So a is minus 1, c is 1. So then we can plug in minus 1 into the first equation. So b is equal to 1. Okay? So we can rewrite our integral as minus 1 over x plus 1 over x squared plus 1. Okay? First term is just natural log, right? And then this guy over here, whoops, I can break up into 2 separate integrals. The second one should be familiar, that's arctangent. This one over here in the middle, you can do the substitution. U is x squared plus 1, d is 2x dx. So I did that in my head. After the substitution, you integrate and back substitute, you should get half ln of absolute value x squared plus 1. Okay? And then, as I said, this integral over here is arctangent. Okay? So this is my final answer right here. All right, so again, the clue was rational function, partial fraction decomposition was probably a good idea, especially because the bottom was factorable. Hopefully this was helpful. Hopefully this is a good practice if you're studying for an exam. This is, I would say, a typical level problem, so you should know how to do this. Hopefully see you in another video as well. Bye.